Some of you have asked for a video about some of the work from the exponential functions homework, so here we go. Number 1 says f of x, function in terms of x, equals 1/3 times 6 to the x power at x equals 2. So all you got to do with this is replace x with 2. That's what it's telling you. We're telling you the input for x is 2. So we're going to use the order of operations here. So the first thing we need to deal with is 6 to the x, which is now 6 to the second power. So I'm going to open up a Desmos, and 6 to the second power is 36. So I've got a 36 that I'm dealing with. All right. Now, that 36 is being multiplied times 1/3, and 1/3 of 36 is 12. So 1/3 times 6 squared is 12, and there you have your answer. Let's take a look at the next one. Next one says the function in terms of n for 10 times 2 to the n power at n equals 5. All right, so number 2 is telling us our input n has to be 5. So we're going to solve basically the function in terms of 5 for 10 times 2 to the 5th power. So we're replacing n with 5. So the first thing we got to deal with in the order of operations is going to be exponents, because that's the most complex operation we have. So 2 to the 5th power is our first thing we've got to deal with. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2, or 2 to the 5th, which is 32. And then that 32 needs to be multiplied by our coefficient of 10, which will bring us to 320. So 10 times 2 to the 5th is 320. And that solves that one. Now, this first set of problems is really training you for the graphing, because in the graphing, you're going to need to pick some inputs and come up with a table of x, y values that you can graph. So I will go ahead and finish 3 and 4 really quickly. So number 3 says f in terms of n, the function in terms of n equals 10 times 2 to the n power, where n is -2. So that means we're going to be dividing by 2 and then dividing by 2. So we have to deal with the exponential part first, which is 2 to the -2 power. That means we've got 2 to the -2 power is 1 divided by 2 divided by 2 again. Okay, only I didn't do it right. So 1 divided by 2, and really we could say 1 divided by 2 to the second power. So that's 0.25. So 1 over 2 squared, and then we're going to multiply that times 10. So 1 over 2 squared times 10. So 10 times 0.25, or 10 times 1/4, is 10/4, or 2.5. Okay, and there we have our answer for number 3, 2.5. Our last one, we've got 1/5 times 1/3 to the x, where x equals 3. So the function in g in terms of x, we're replacing x with 3, so we got g in terms of 3. 1/5 times 1/3 to the 3rd power. So we got to raise 1/3 to the 3rd power. Okay, 1/3 to the 3rd power is not going to look very good on Desmos. It's going to try and give me some sort of decimal goodness. I'm going to stick with fractioniness, but that's 1/3 to the 3rd power, which is going to be the same as 1 over 27, because 1 to the 3rd power is 1, and the denominator of 3 to the 3rd power is 27. You can see by this long, annoying decimal, which you should not use, that except for the purpose of confirming that 1/27 is the same as 1/3 to the 3rd power. Can we go over here? And now we've dealt with the exponential part. We need to multiply times 1/5. Okay, we're going to multiply times 1/5. So what we need to do is figure out well, 1 times 1 will be 1. And now we deal with our denominator. 5 times 27. Our denominator will be 135. Okay, so we're going to have, our answer is going to be 1/35. So 1 over 135. And that is our answer. If you did as a decimal, you would have gotten something like this repeating thing that goes 0.00740740740 forever. That 1 is just a product of rounding. And now let's take a look at 5, 6, 7, and 8. Okay, so number 5. And you should pause at any point you need to reflect on any of this or try any of this. Number 5, it's giving us the function, and instead of just one value we want to evaluate, we're going to evaluate a whole set of them. And you've got x values down here that we can treat as inputs to get y values. So the easiest one to get is 0. So 4 times 2 to the 0 power is going to give us 4 times 1, because 2 to the 0 power is 1. So we're going to have a point at 0, 4. So we'll go over here, and I'm going to go down here. We will plot 0, 4. Cool, we've got that point. Now, we go back, we can plug in 1. Okay, 4 times 2 to the first power is just 4 times 2. Okay, 4 times 2 is 8. So we've got a point at 1, 8. All right, we'll pick one more. Let's pick a point for 2. So that one, we have 0, 4. We have 1, 8. All right. How about 4 times 2 to the second power? 2 to the second power is 4. So we've got 4 times 4. So we're going to have 2, 16. So I've got 2, 16. I'm going to zoom out so you can see those points. Okay, there you have our points. Now, I'm going to plot a couple that go back this way. So we're going to do 4 times 2 to the negative 1. And 2 to the negative 1 is 1 over 2, because negative exponents are reciprocators. They make you become a reciprocal. So 4 times 1/2 is just 2. So negative 1 gets us 2. And you can start to see a nice curve developing here. We'll pick one more point, which is going to be negative 2. So x will be negative 2. 2 to the negative 2, we've already figured out, is 1 over 2 squared, or 1 over 4. But 4 times 1/4 is 1. So we've got a point at negative 2, 1. Okay, there we have probably enough points to start graphing our line. If you want more, you could get more. If you went to x equals 3, you'd have 4 times 2 to the third, or 4 times 8. 4 times 8 is 32. That's going to be off the graph. If you want to go the other way, 4 times 2 to the negative 3 is 4 times 1/8. So that's going to be negative 3, 1/2, because 4 times 1/8 is 1/2. So yeah, sure, I'll go ahead and plot that one. Negative 3, 1/2. And we plot the function 4 times 2 to the x. It goes right through all of that. All right, I hope that seeing that approach, where we're just going to plug in inputs using the x values that we've got, starting with 0 and building back and forth from there. I want you to notice, though, a couple of things, just a couple of things. When I made x equals 0, my y value was 4. Now look in this function where 4 shows up. 4 is right here, because when I make x equal to 0, the exponential part just becomes 1, and we no longer care about it in our multiplication problem. So our initial value becomes the most important part. It becomes the only important part for solving for y if x is 0. On the other hand, if x is 1, then we don't really need to care about the exponent anymore. Our y value is just 4 times 2. So it's our initial value times our base, because the exponent doesn't do anything to 2 except leave it alone and be there. So 4 times 2. So you've got 2 points very easily. 4 and then 8, because that's 1. X is 1 makes us 4 times 2. Okay. And since you probably have noticed that we've got a times 2 thing happening here, so you can go 4, 8, and then we'll have 16. You can start thinking it through. We're counting in a times 2 sort of way, going backwards in a times 2 sort of way from 16 to 8 to 4. We're going to go to 2, and then 1, and then 1/2, and then 1/4, and then 1/8, and 1/16, and 1/32, and on and on and on. The next one is going to be counting in a times 1/2 sort of a way, or you could think of it as a divided by 2 sort of way. And the one after that counts in a times 3 sort of way, or counts in a 1/2 sort of way again, or divided by 2 sort of way. So in each one of these, use the x values at the bottom, starting with 0 and 1, and then branch out in either direction from maybe -3 out to 3. At some point, it's going to go off of the graph, and it might go this way, it might go this way. And at some point, it's going to become so small on one side or the other that it may as well be just a hair above the x-axis. So if you graph the stuff in the middle, like these 5 or 6 x points, you've got your exponential function. Your y-intercept will be really useful for you. In this case, our y-intercept when x equals 0 is going to be 1/2, because 3 to the 0 is going to be 1, for example. Okay, so I hope this has been helpful to you, and I'm going to stop the video now.